Hi everyone, welcome to our second installment of Chemistry with Katie and Mamadre. So we're going to take our understanding of precipitation reactions to the next level, and we're going to describe them using three different types of equations. We're going to use what we've been using and writing is our molecular equations. What are our molecular equations? Those are the complete ionic equations for the reactants and the products. We're then going to show what these actually look like in solution, meaning we know ionic compounds break up into their ions. So we're going to write these as ions. And then what we're going to say is, you know what? If there's ions that remain unchanged on both the reactant and the product side, we don't have to include those. We can cross them out and only write the ones involved in the precipitate. Okay? So the ions that aren't involved in the reaction, meaning aren't involved in the product, are what's called spectator ions. Okay? I'm going to put these slides in Veracross so you have them, but we're going to show you what I mean right now. Remember, when ionic compounds dissolve in water, they break up into the ions. If two of the ions come together into an insoluble solid, that's called a precipitate. And that is the driving force for a chemical reaction. Okay? So what we've been doing is a complete molecular equation where we write our reactants and our products and we balance the equation. We're going to break up our reactants into their ions. Okay? Lead is a +2 ion, and I have 2 nitrates. Each of them is a -1 ion. I have 2 sodium ions and 2 iodide ions. Okay? But we know that 2 things come together, namely lead, iodide, come together and form an insoluble precipitate, and then sodium and nitrate aren't involved. There are spectator ions. They're the same on both sides, so let's clean this up by canceling out anything that remains unchanged on both sides. We can then write a nice and neat net ionic equation that only involves the ions involved in the reaction. My lead +2 and my 2 iodide ions forming my lead iodide. And it should be balanced. All right, so we're going to get Katie involved in helping us out with this example. So wait, before you go anywhere, let's talk about what we're going to do. We're going to look at our example. A solution of potassium chloride. We have to remember how to write ionic compounds. In water means it's aqueous. Reacts with aqueous silver nitrate to form a precipitate. Okay, so everyone should get out a piece of paper and let's try to write this. We're going to identify the precipitate using our solubility table, that yellow sheet that I gave you yesterday. We're going to write down the molecular equation. We're going to write down the ionic equation, and then we're going to cancel out our spectator ions and write our net ionic equation. All right, Katie, let's help us out here. So what did we start with? Potassium chloride.
You can just do it on the board.
Okay, right, potassium chloride.
Okay.
And it's aqueous. So we don't need to actually write in the water, plus aqueous silver nitrate to form a precipitate. How do we know which one is going to precipitate? Well, we're going to do our double replacement reaction, and we know potassium is going to get together with nitrate. Conveniently, they're both +1 and -1. And our silver is going to get together with our chloride. Okay? We know from our solubility rules that potassium is always soluble and nitrate's always soluble. So we know potassium nitrate is not our precipitate, and silver chloride. Chloride is typically soluble, but silver is an exception. All right, Katie, let's write our ionic equation now. K plus Cl minus plus NO3 minus. Okay. Now we know that potassium nitrate will stay as ion, so it's K plus NO3 minus. But this is a compound. This is our insoluble, so it stays together. Okay. What can we cross out on both sides that stays the same? Beautiful. Our potassium crosses out, our nitrate crosses out. So our net ionic equation would be Cl minus plus Ag plus. The order of those does not matter. It could be Ag plus and then the Cl minus, and then we'd write our solid at the end, S. And that is our net ionic equation, guys. Let's try another. So come on over to the screen. All right, so this is what we just showed you. Okay, this is what it would look like in solution. We have our ions that remain and our solid silver chloride on the bottom. Okay? All right, let's try aqueous. Everyone should be doing this on their own at home in their notebooks. Aqueous potassium hydroxide is mixed with aqueous iron 3 nitrate to form iron 3 hydroxide and potassium nitrate. In fact, I didn't even need to tell you that product. You should be able to figure that on your own. Take a look at the solubility chart. Oops. Take a look at your solubility table. Figure out what the precipitate will be. All right, Katie, show us how you do it. Potassium hydroxide. Katie, talk us through what you're thinking.
All right.
Well, then you won't know that it's balanced yet.
Okay. Okay. All right. So potassium hydroxide plus iron
3 nitrate.
Okay. And then you make the solutions. So KNO, I'll do it on the bottom. And then you balance by putting 3 and a 3.
Okay, so now we're going to write the ionic equation. Katie, talk us through what you're doing.
I'm splitting it all up.
Okay. She's writing all the ions. Okay.
Yes, that's what I'm doing.
And see how she's adding the balanced equation, the coefficients, so that there's 3 Ks and 3 OHs. Fe is a +3, and then there's 3 NO3s. Okay. That's important. Okay. And then can you show us how you cross out the spectator ions?
This is the same, and this is the same. And this is the same, and this is the same.
Okay, so now let's write our net ionic equation. Awesome. All right, so let's look at the lab and grab, if you could pass me the lab. Okay, awesome. So we're going to take a look, and for each square, hopefully you have a description of the precipitate that you saw in the first video. Katie, which square do you want to write the net ionic equation for? So she's going to write the net ionic equation for this one right now, and also you'll see that the first one was done for you. All right, show us how you do that, Katie.
All right, so we already have it balanced. So 2KOH plus CuSO4 goes to K2SO4. Am I going to have enough space? No, I'm not.
It's okay, just write it below.
CuOH2. Beautiful. And this is the solid. Okay. Now it's 2K plus 2OH minus plus Cu plus 2 plus SO4 minus 2 goes to 2K plus SO4 minus 2 plus CuOH2. And then cross this out, cross this out. 2OH minus plus Cu plus 2 goes to CuOH2. Solid.
Awesome. So, what do you think? For a time-saving step, you could, for the lab, skip this step, right? Once you recognize what the precipitate is, right? And you know that it's here, you could skip straight from the molecular equation to the net ionic equation. With practice, I think you guys can save yourself some time and eliminate this middle step, okay? So your homework is to finish up this lab with net ionic equations. Check there across, and I will also be sending an email. Bye.